Hi there. In the last video I explained how to work out the transpose of a matrix. Okay. In this video I'm going to explain how to work out the inverse of a 3x3 matrix. So we're going to use the idea explained in the last video, the transpose of a matrix, and we're also going to use the idea of how we can work out the determinant of a 3x3 matrix in order to work out the inverse of a 3x3 matrix. Okay, so let me title this inverse of a 3x3 matrix. So let me underline this. So remember the general idea of the inverse of a matrix. So to work out the inverse of a matrix A, it's 1 over the determinant of that matrix, okay, multiplied by the adjoint matrix. Okay, so also remember that you can only work out the inverse of a matrix if the determinant of that matrix is not 0. Okay, now let me show you how to work out the inverse of a 3x3 matrix. So in this case, let me take an example, and let me use this example to explain the steps. Okay, so example number 1. So we're going to find the inverse of, and let me call this matrix A. So A is defined by -1, -1, 1, 0, -1, 3, and 2, 1, 2. Okay, so let's work out the inverse of this 3x3 matrix, and let me explain the steps involved. So remember, to work out the inverse, it's 1 over its determinant multiplied by the adjoint of this matrix. Okay, so in this case, step 1 for me is to work out the determinant of this matrix. Okay, so let me write down the steps in red. So find the determinant of the matrix given. Okay, so I'm going to calculate the determinant by expanding using the first row. Okay, so the signs associated with the first row of this matrix of a 3x3 is plus, minus, and plus. So remember, these are the signs associated with the first row. Okay, they're also signs associated with the second and third rows also, and you could also work out the determinant using any row or any column. Okay, but I'm going to use the first row. So plus, minus, and plus, the signs associated with the first row. So when I work out the determinant of A, it's plus the first element, which is -1, multiplied by a 2x2 determinant. So to find the elements of this 2x2 determinant, we ignore the row and the column involving that first element. So if I ignore the row and the column involving -1, the elements of this 2x2 are -1, 3, 1, and 2. Okay, minus the second element, so minus of a -1, multiplied by, and if I ignore the row and the column involving that second element, the elements of this determinant will be 0, 3, 2, 2. So 0, 3, 2, 2. Plus the third element, so +1, multiplied by another 2x2 determinant, and the elements of this determinant are found by ignoring the row and the column involving that third element. So if I ignore the row and the column, the elements are 0, -1, 2, 1. Okay, so let's simplify this. So it's -1, open a bracket, remember, to calculate a 2 by 2 determinant, the idea is multiply the elements along the leading diagonal. So I highlighted it in red. So minus 1 times 2, minus 2, minus, and then multiply the elements along the opposing lateral diagonal, highlighted in green. 3 times 1, 3. Okay? Minus into minus 1, which is plus 1, open a bracket. Same idea here. Multiply the elements along the leading diagonal. 0 times 2 is 0, minus. Then multiply the elements along the lateral diagonal, highlighted in green. 3 times 2, 6. Plus 1, multiplied by, multiplying the elements along the leading diagonal. 0 times 1, 0, minus. Then multiply the elements along the lateral diagonal. Minus 1 times 2 is minus 2, with this minus, plus 2. Okay? So if you're unfamiliar with this idea, I explained this approach along with some examples in an earlier video, so be sure to check that video, okay, to help you with the understanding of how to work out a 3 by 3 determinant. Let me continue. So 3 rather is minus 5 times minus 1 plus 5. 0 minus 6 is minus 6 times 1 minus 6. 0 plus 2, 2 times 1, 2. So if we simplify this, 5 minus 6 plus 2 gives us a determinant of 1. Okay? So that is step number 1. Step number 1 is to work out the determinant of that matrix. Step number 2. Now we have the determinant. Okay, we need to work out the adjoint. Okay, so let me show you how to work out the adjoint of a 3 by 3 matrix. So step number 2, find the adjoint. Now part 1 of step number 2 is to find A transpose. Okay, so I like to find A transpose firstly in order to work out the adjoint. Okay, so A transpose. So in an earlier video, so in the previous video, to work out the transpose, remember the rows of your matrix will become the columns of your transpose matrix. So going back slightly, the first row of A, minus 1, minus 1, 1, that will be the first column of your transpose matrix. Minus 1, minus 1, 1. Okay. The second row of A, 0, minus 1, 3, that will be the second column of your transpose matrix. 0, minus 1, 3. And the third row of A, 2, 1, 2, that will be the third column of your transpose matrix. 2, 1, 2. So remember, rows of your given matrix will be the columns of your transpose matrix. Okay. Once you've done that, so that's part 1 of step 2. So let me continue on the reverse. Now part 2, eventually work out the adjoint. And to work out the adjoint, now what I usually do is, on the corner of my script, I write down the signs associated with each of the rows of a 3 by 3. It's plus minus plus for the first row, minus plus minus for the second, plus minus and plus for the third row. Okay, and I use this to work out the adjoint. So to work out the adjoint, this is what we need to do. Now to work out the first element, so for the first element, write down the sign associated, so it's plus. Okay, then go back to your transpose matrix and then write down the minor of that element. So remember the term minor of the element is the determinant of a 2 by 2, and the elements of that 2 by 2 can be found by ignoring the row and the column involving that element. So minor of -1, so it's the determinant of a 2 by 2, and if I ignore the row and the column involving that element -1, the elements of the 2 by 2 are -1, 1, 3, 2. Okay, so let's write that down here. So the elements of that 2 by 2 in this case are -1, 1, 3, 2. So let me repeat. So first write down the sign associated with that element, and then write down the minor of that element. Let's practice with the remaining elements. So for the second element of row 1, sign associated is minus, and then we write down the minor of that element. So the minor of this element over here. So if we ignore the row and the column involving that element, the elements of the 2 by 2 are -1, 1, 1, 2. Okay? So it's minus determinant of -1, 1, 1, and 2. Okay? Now, let's continue. Third element of row 1, sign associated is plus. And the minor of that element, so if we go to the reverse, so look at your transpose matrix, ignore the row and the column involving that element, and the elements of that determinant are -1, -1, 1, 3. Okay? So let's jot that down. -1, -1, 1, 3. Okay? Now let's practice with the second row. So first write down the sign associated, so minus. Then note down the minor of that element. Okay, so the minor of -1, ignore the row and the column. So the elements of that determinant would be 0, 2, 3, 2. So 0, 2, 3, 2. Okay. Second element of row 2, sign associated is a plus. So write down plus. Then let's figure out the minor of that element. So if we go to our transpose matrix, minor of -1, ignore the row and the column. So the elements of that determinant are -1, 2, 1, 2. So -1, 2, 1, 2. Okay. Third element of row 2, sign associated is a minus. Let's go back to our transpose matrix and work out the minor of that element. So the minor of 1, ignore the row and the column associated with that element, and the elements of that determinant are -1, 0, 1, 3. So -1, 0, 1, 3. Okay. So let's also practice with the third row. So the sign associated is plus. Now we need the minor of that element, so let's go back to our transpose matrix. Minor of 1, so if I ignore the row and the column, the elements of that 2 by 2 would be 0, 2, -1, 1. So 0, 2, -1, 1. Second element of row 3, sign is a minus. Go back to your transpose. Let's figure out the minor of that element. So ignore the row and the column. And the elements of that determinant are -1, 2, -1, 1. So -1, 2, -1, 1. And last but not least, sign associated with the third element of row 3 plus, and go back to your transpose, minor of that element 2, so ignore the row and the column, and the elements of that determinant would be -1, 0, -1, -1. So -1, 0, -1, -1. So, and if we calculate these 2 by 2 determinants and multiply by its associated sign, you would eventually work out the adjoint of the 3 by 3 matrix. So, remember, to work out the determinant of a 2 by 2, multiply the elements along the leading diagonal, then subtract, then multiply the elements along the lateral diagonal, okay? And if you conduct that procedure, you should have your adjoint matrix to be -5, 3, -2. So these should be the elements for the first row of the adjoint matrix. For the second row, I had 6, -4, and 3. And for the third row, I had 2, -1, 1. So remember, to work out a 2 by 2 determinant, multiply the elements along the leading diagonal. So -1 times 2 is -2, minus, then multiply the elements along the lateral diagonal. 3 times 1 is 3, so -2 minus 3 is -5. Okay? Times, multiply that by the sign associated should give you the element for that particular row, okay, of your matrix. So that is the procedure to working out the adjoint A star. And in the next step, so next step is step 3. Step 3 is to use the result. So for the inverse, it's 1 over the determinant times the adjoint. So in this case, using A inverse, that's 1 over the determinant multiplied by the adjoint. So it's 1 over the determinant in this case. So if we go back, answer of step 1 for the determinant is 1. So it's 1 over 1 multiplied by the adjoint. So answer of step 2, -5, 3 minus 2, 6 minus 4, 3, 2 minus 1, 1. And if I multiply each of these elements by the scalar outside, so 1 over 1 is 1, so multiplying all of these elements by the scalar should give us -5, 3 minus 2, 6 minus 4, 3, 2 minus 1, and 1. Okay, so that is the inverse of the matrix A. Okay. So here are the steps in order to work out the inverse of a 3 by 3 matrix. Okay, and that ends this example and this video. So I hope you found this video helpful. Do related practice questions, and I hope to see you soon. Thank you.